Hey guys, I'm going to be working on Unit 4, which is our Graphing Quadratics unit, questions 43 through 57. My name is Coach Fran. I'm an Algebra 2 level teacher here at the Woodlands High School. I'm just going to walk through some of these with you, and hopefully this answers most, if not some of the questions you might have on this unit. So we're going to start with question number 43. So what it's telling me is to graph f of x is equal to negative 3x squared plus 6x minus 2. So the first thing that we want to notice in Unit 4 is we dealt with two different types of equations, or two different types of forms rather, standard form and vertex form. Now, you're going to hear me reference to these guys a lot throughout this video. So standard form is y equals ax squared plus bx plus c. So this form is important because it helps us be able to factor and find our roots of the function and our x-intercepts pretty easily. But the form that we need to graph from is vertex form, which is y is equal to a parentheses x minus h squared plus k. So vertex form in particular, like I said, is what we graph from. So if they ask you to graph us a particular equation and it's not in vertex form, we're going to have to convert it. So this was in our Unit 4 notes. So what we're going to have to do here is whenever we're graphing from standard form, we have to change it to vertex, like I've said. But when we're changing to vertex from standard, so standard to vertex, how we do that is going to depend on one of two things, and that is what is our a value. In this case, we fall into one of the situations where our a value is not equal to 1. So our a value is our coefficient in front of x squared, our b value is the coefficient in front of x, and our c value is the constant at the end of the function. So the way that we change from standard to vertex is going to depend on whether a is not equal to 1 or when a is equal to 1. And I'm going to go through both different situations here. So when a is not equal to 1, because it's obviously negative 3 in this case, so that's one thing we know. So what I'm going to have to do here, in this case, is when a is not equal to 1, it's actually really not too bad. What we're going to have to do in this problem is we need to use a particular formula. So I'm going to go ahead and go through that to find our h value. So in vertex form, the one thing that we know is our h value and our k value are what make up the vertex, hence vertex form. So in order to write a vertex form equation, what we're going to need is the h, the k, and the a value. Okay, these are going to be the three important variables that we're going to need to fill out in order to get this done. So I'm just going to make a little quick note of there. I need a, h, and k. So what's nice about standard to vertex is that regardless of the form, notice I have an a value in both formulas. And the a values represent the exact same a. The a in standard is the same thing as the a in vertex. So really what I know right now is my a value is negative 3. What I need to know is the h and the k value, which is what we're going to do next. So there's a formula to find h. When the a value is not equal to 1, that formula is negative b divided by 2 times a. So what I have to do is take my b value, which I know already is 6, and multiply it by a negative, and then divide it by 2 times whatever my a value is. So I'm just going to substitute these two numbers into this formula to find my h value. So the h value is going to be negative 6 over 2 times the negative 3. Simplifying this a little bit, I get negative 6 over negative 6, which simplifies to 1. So keep in mind, the vertex, h and k, is still a coordinate on the coordinate plane. H is really just an x value. It's just a special x value, and k is just a special y value. we just give them different variables to represent the vertex in particular and separate it from every other point on our equation, or on our graph, excuse me. So I know this h value is really an x value. So the only thing I need to know now, so I know h is 1, is that I need to know the k value, which the k is a y value. So in order to find the y value given the x, all I have to do is to plug this x value, or h, into my equation, which they gave us, in for x, and then solve. Keep in mind, f of x is the same thing as y. So what I'm going to do is take this equation, 3x squared plus 6x minus 2, and everywhere there's an x, I'm going to substitute 1. So what I have now is negative 3 times 1 squared plus 6 times 1 minus 2. Simplifying that, whenever we're simplifying or solving, use order of operations. So we're going to solve the 1 squared first. So this is the same thing as negative 3 times 1 plus 6 times 1 is 6 minus 2, which is the same thing as negative 3 plus 6 minus 2, which, doing a quick little mental math, is 1. So this is my k value. Keep in mind, this is just a special y value. So I know all three of the important points here to write my vertex form equation. Because keep in mind, all of this that we're doing is just setting up the graphing portion of this question, because they're asking me to graph. So in order to graph, I have to change forms first. It might seem like a long process, but that's just because I'm slowly going through it. Keep that in mind. So my final equation before I start graphing, okay? So we're going to substitute A, H, and K into vertex form. So my equation here is y is equal to negative 3, which is A, times x minus h, so minus 1 squared plus 1. So we can graph this. What we have to do here is create our parent function table for a quadratic, which we talked about in the past as negative 2, negative 1, 0, 1, 2, and the points 4, 1, 0, 1, 4. So notice I do have the same y values on either side of 0. So you're going to see a typical pattern form. So this is my parent function. This is the table of my original function before I've applied the transformations negative 3, negative 1, and 1 to it. So what we have to evaluate is which of these three numbers, negative 3, negative 1, and 1, are changing the y, and which ones are changing the x. So what we've talked about in our transformations units is that every number outside of the parentheses is affecting the y. So what I notice here, in this case, is I have two numbers that are not in parentheses. Those numbers are negative 3 and positive 1. So these two numbers are going to affect our y values. Negative 3 is a coefficient, so it's multiplying, and 1 is a constant, which is adding, hence the addition sign. So that's what's happened. That's what we're going to be doing to all of these y values in this table. Is we're taking negative 3 times f of x, or the y values, and then add 1 to them. So I'm taking each of these y values, multiplying them by 3, and then adding 1. So looking at the first value, negative 4 times negative 3, or excuse me, 4 times negative 3 is negative 12, and then negative 12 plus 1 is negative 11. And then going down, 1 times neg 3 is neg 3 plus 1, which is negative 2. 0 times negative 3 is 0, plus 1 is 1. And then the same y values will repeat on the opposite side. Now, our x values change if there is a number in the parentheses. So looking here, I notice I have a minus 1 inside. Now, the rule of thumb that your teacher might have told you this year is that x lies, meaning we're going to do the opposite of what it says inside of the parentheses. If it says x minus 1 inside, what we're actually going to do is x plus 1. So we're going to add 1 to every x value, which is pretty simple to do. So these are the points now I need to graph. It's an ugly green. So being that I've changed the x's and the y's, these new y's and these new x's are going to represent my new function that I'm going to graph. So we're finally there. These are the coordinates I'm going to graph. So your review didn't have a graph given to you, so you probably just have to sit there and make one, which is why obviously I have a coordinate plane here. So we don't have to make it so large. Okay, if certain points aren't going to fit on your coordinate plane, that's fine. For instance, negative 11 for the y values don't fit, so that's fine. Now we can kind of guesstimate where that's going to be, which is okay too. So my x value is negative 1, y value is negative 11. I'll say it's somewhere down here. Then I have 0, negative 2. 1, 1. 2, negative 2. And then 3, negative 11. We'll say it's somewhere down here, just to represent it. So this is what we call a parabola. And this is the graph of this function. So we went through a lot, but like I said, keep in mind that it's a lot of just conversation points that we went through in the beginning. Okay. The one thing that you're going to see me talk about first, whenever I'm going from standard to vertex in particular, okay, is what is that a value. So this here is the most important part to evaluate in the start. Now, if it's already in vertex form, we can skip all of this in blue that we did and just get right into the red. But we couldn't in this case. So going ahead and moving on. For number 44, that problem was once again to graph. And they're saying t of x is equal to 1/2 x squared plus 2x minus 1. Once again, here we go, standard form again. So, like I said, in order to graph this, we want to go from standard to vertex form. We need to. So looking at the a value in this case, my a value is 1/2. So once again, here we go. My a value is not equal to 1. So all that means in this case is that I have to use that h formula once again. So when a is not equal to 1, I have to say h is equal to negative b over 2a. And we're going to follow the same pattern we just did. I need to know three things: a, h, and k. A we already know. It's in the formula, which is nice. So we're going to find the h value and the k value. So my h in this case is equal to negative my b value, which is 2, over 2a. So 2 times 1/2. A negative times the 2 up top is negative 2. And 2 times 1/2, so we're saying what is half of 2, which is 1, is equal to negative 2. Like I said, keep in mind this is an x value. So to find the k value, we plug it into my original problem. So x squared, 1/2 times x squared plus 2x minus 1. Substituting this -2 in, I get 1/2 times -2 squared plus 2 times the -2 minus 1. Order of operations, okay, keep that in mind. That's a big thing here, is I need to do exponents first. So the -2 squared, -2 times the -2 is 4. So this is 1/2 times 4, really. Then 2 and a -2 is a -4 minus 1. Half of 4 is 2 minus 4 minus 1, which is -3. Keep in mind this is a y value. So we know everything, once again. So I'm going to use all 3 of these points in vertex form. Y is a times x minus h squared plus k. And now we're just going to substitute. So y is equal to 1/2 times x minus h. Okay, so it's minus a -2 squared minus 3. So 2 negatives inside is really going to make that turn into a positive. This is our vertex form. Now, that's not what they're asking us to do, but we need this in order to graph. So just like last time, we need to evaluate when graphing what numbers are outside versus what numbers are inside the parentheses. I have 2 numbers outside, a 1/2, which is multiplying, and then a 3, which is being subtracted. And then what I also have is a +2 inside. So I'm changing both the x's and the y's here. So making my table, we always want to start off with our parent function, which these points you will have to have known. So I'm changing the y's, like we said, by multiplying by 1/2 and then subtracting 3. And then the x's, I'm doing the opposite of what's inside because x lies. So it's -2. So just something to note, where am I getting these numbers? The -2 comes from the +2 inside, and the 1/2 and the -3 come from the outside numbers. So now working this, I'm multiplying every y value by 1/2, or halving it, and then subtracting 3. So 4 times 1/2 is 2, and 2 minus 3 is -1. Half of 1 is 0.5. 0.5 minus 3 is -2.5. Half of 0 is 0, minus 3 is -3, and then the points mirror. My x values, all we're doing is subtracting 2 from them. So -2 minus 2 is -4. Then -3, -2, -1, and then 0. So like I said last time, these are the new coordinates that I'm going to use. Or these are my actual coordinates of this equation. So when I'm graphing this, I'm going to use this column to represent my graph. So I'm going to graph -4, -1, -3, and -2.5. So zoom in a little bit so you can see. So -3 and -2.5, roughly there. -2, -3, -1 and -2.5, and 0, -1. So this is my parabola here. Feel free to pause at any point during this video. It will be long, but it is in full detail, should you want to pause and look over any problem in particular. The next problem here, number 45, it's asking us to graph. Oh, look, a vertex form. This is easy. Well, at least easy in terms of the amount of work we have to do. So I'll rephrase, it's much less. So we have to graph h of x is equal to 2 times x minus 2 squared plus 1. So notice it's in vertex form already. Okay, so we don't have to change forms here. We can graph it. We can graph this guy right out. So what we have to obviously evaluate, like we've been doing, is notice we have numbers outside the parentheses. Oops, excuse me. We have 2 and 1. And then we have numbers inside, which is minus 2. So working this, I'm going to write my parent function table, as we've been doing to start. Since I'm changing my y's and x's once again, I'm going to expand this table. Keep in mind, just a note, you're not always going to change both x and y. It just depends on the problem. Sometimes we'll change x, sometimes we'll just change y, sometimes both. So I'm multiplying my y's by 2 and then adding 1, hence the blue highlighted numbers. The x's, x lies, so we're going to do the opposite of it, so add 2. So we're taking all of our y's, multiplying them by 2 and adding 1. So 4 times 2 is 8, plus 1 is 9. Then I have 3, then 1, and then those values mirror. X's, relatively simple. So these are my new coordinates. So graphing this, I'm at 0, 9. So 0, 9, 1, 3, 2, 1, 3, 3, and then 4, 9. And there's my graph. So talking about the next one, number 46. Once again, k of x is equal to x plus 3 squared plus 2. So once again, vertex form. So parent function table, -2, -1, 0, 1, and 2. 4, 1, 0, 1, 4. My y's in this case are just adding 2 because there's no coefficient out front. So I don't have to multiply in this case. So in this case, I'm just adding 2 to the y's. And inside, it's plus 3, so we're really going to subtract 3. So quickly adding 2 to all of these numbers. And then subtracting 3. Once again, these are my coordinates. Plotting this really quickly. So negative 5, 6. Negative 4, 3. Negative 3, 2. Negative 2, 3. And then negative 1, 6. And there's my graph. So, all done with the graphing, which is convenient. So like I said, if feel free to go back onto any of these problems at any point, should you feel inclined. It's no big deal. Okay. So now, let's move on to 47. So what they're asking us to do here is convert. What they mean by convert is to change forms. And that's either from standard form to vertex form or from vertex form to standard form. So those are the two situations that they're talking about. We already know one of them, well, a part of one of them. So we'll talk about all the other situations. So for 47, looking at that, keep in mind what they give us. In this case, it is f of x is equal to x squared plus 14x plus 40. So this is standard form, and we've already done standard form to vertex form in our first two examples today. But keep in mind, when I'm going from standard form to vertex form, okay, there's two methods. Like I mentioned earlier, one method is when a is not equal to 1, which is what the first two examples today talked about. And one is when a is equal to 1, like in this case. And the way that we get that done changes. So in this case, the a value is an understood 1. When the a value is equal to 1, what we have to do here is a method called completing the square, which is going to involve factoring. So, when completing the square, what we want to do is take our function, and the first step that we're going to take is set our equation equal to 0. So there we go. 0 equals x squared plus 14x plus 40. So step number 1, set our equation equal to 0. Done. So the second thing that we're going to do is to always move the c value to the other side. Keep in mind, this is a, this is b, and this is c. So when I do that, I now have negative 40 is equal to x squared plus 14x with nothing. So what we want to do here for step 2 is move our C value to the opposite side. So what we have to do here is we need to find a new C value. So we're going to create a new number that's going to be added to the side. That's not going to be the same as our old number. Now, like every math problem, if I'm going to add something to this side, I'm also going to need to add something to the opposite side. So realistically, what we're going to see is we're going to see something added to both sides of this problem. So where these lines are, I'm going to put a number. It's going to be the same number. Now, how do we get that number? So what we have to do here for step 3 is we are going to create a new number and we're going to add it to both sides. And what we're going to do is take the b value, divide it by 2, and then square that. So in this case, what that's going to look like for us is b over 2 squared is obviously going to involve our b value, which is 14. So we're going to say 14 over 2 squared, which is 7 squared, which is 49. So this is going to be an important number for us. So that number is going to go right here in both of these places. And I'm going to add it to both sides. Keep in mind, I'm adding that guy. So I'm going to add 49 to both sides. Now, step number 4 now, get back to my color scheme. Excuse me, is I want to factor this new quadratic that I just created. Okay? How we're going to factor that is using our ACB chart. So my AC value is 1 times 49, which is 49. My B value is 14. So the nice thing about this, for this form only, is for completing the square. Okay. Both factors must be the same. So thinking about what are factors of 49 that add to 14, these numbers must be identical. So the numbers that we're looking for here are 7 and 7. Because 7 times 7 is 49, and 7 plus 7 is 14. So since they're going to be the same, how I'm going to write that is going to be, instead of x plus 7 times x plus 7, I'm going to make this start to look like vertex form. So I'm going to combine those and simplify it and say that this is x plus 7 squared, because I'm multiplying two x plus 7s by each other. Keep in mind, this still equals this guy. So in this case, negative 49, or 49 minus 40, let's simplify that to 9. So now the last step here we're going to move this constant back over to make our vertex form. So how I'm going to move a positive 9 is by subtracting it. I can't subtract it from x plus 7 squared, so I'm going to subtract it outside. And notice this minus 9 is going to become our k value. So that just becomes 0 now, equals x plus 7 squared minus 9. So now let's just kind of revert that last step. And instead of putting a 0, let's put a y. So now this is our general equation. Y is equal to x plus 7 squared minus 9. So the one thing to remember here is that when you factor that quadratic that we create from the b over 2 squared value, the factors should always be identical. So that's going to really help narrow down your values. So moving on there, that was number 47, I believe. Yes. So let's go on to 48. So for 48, we're converting again. And it's once again a standard form. So this is just g of x is equal to 2x squared plus 8x plus 10. So the first thing that we talked about, changing from standard to vertex, okay, is recognizing what situation we have. Okay, from standard to vertex, are we doing an a equals 1 method or an a is not equal to 1 method? Okay, noticing here, a is not equal to 1. So we're going to use h is equal to negative b over 2a again. So recognizing our a, b, and c values, I'm going to change this to vertex form. So in this case, h is equal to negative b over 2 times a, which is 2, which gives me negative 8 over 4, which is negative 2. Like we said, the h is still an x value, just a very particular x value. So how I find the k value now is I take this negative 2 and I'm going to substitute for x in the equation. So I'm going to take g of x is equal to 2 times negative 2 squared plus 8 times negative 2 plus 10. Order of operations, I need to square first. Pemdas. So negative 2 squared is 4, and 4 times 2 is 8. Like I said, because this is really 4 times 2. Keep that in mind. And then 8 times negative 2 is negative 16 plus 10. Doing a little mental math. Okay, just make sure I wrote everything down correctly. Just double checking myself real quick. Okay. So 8 minus 16 is negative 8 plus 10. Negative 8 plus 10 is 2. Which is my k value. Keep in mind, it's a k value, but it's just a special y value. So I have everything I need because I already know the a value, going all the way back to the original problem. Because for vertex form, I need the a, h, and k values. So writing these in the formula now, I now know y is equal to my a value, which was 2, times x minus negative 2 plus 2. So if you want to just think about that h in the parentheses as always being the opposite sign in the formula as to what it really is, you can think of that as well, so you don't have to necessarily add one additional step. So this is really x plus 2 squared plus 2. What I mean by what I just said was that if we know that the h value is negative 2, you can go back and notice a pattern with all these problems that we've done, going from standard to vertex, is the h value is always the opposite sign in the equation to what it really is. If it's a minus 2, in reality, in the equation, it lies to us if it's plus 2, hence x lies. So this is my final answer. Going on to 49, something we haven't talked about yet, but we really save the easier stuff for the end. So in this case, for 49, we're converting. But notice what they're giving us here. Vertex form this time. So I have negative 2 times x minus 4 squared plus 1. So all I've got to do here is I want to multiply out all of the parentheses, get rid of the square, and just combine everything. So we're going to kind of have a little bit of a 3-step process to do this. Okay? Number one big thing is we need to follow Pemdas. You are going to screw up if you don't follow that good old Pemdas. So in this case, what we're going to do here is notice there's no parentheses to simplify, but there is an exponent. So the first thing that we're always going to do is we're going to multiply. I'll write this in red. Not multiply, we're going to FOIL out our parentheses. So what we're going to do is take this bit of parentheses here, this x minus 4 squared, and separate it. What I mean by that is, just like we talked about earlier, x minus 4 squared, just like a couple problems ago, is really 2x minus 4 together. Like here, what we talked about is 2x plus 7, so when I factor this, is the same thing as x plus 7 squared. That's just a shorthand way of writing it. So I'm going to break this apart. So I really have x minus 4 times x minus 4 there. So I'm going to multiply this out first. Foiling meaning front, outer, inner, last. So 4 different multiplications going on. Okay, so let's go one at a time. X times x is x squared. Outer, x times negative 4, negative 4x. Inner, negative 4 times x, negative 4x, and negative 4 times a negative 4, which are 2 last terms, positive 16. I can combine those middle terms to give me x squared minus 8x plus 16. But keep in mind, this is just me multiplying out that red box. I've still got a plus 1 and a times 2 on the outside. So we're going to go ahead and bring those guys back into the play here. So negative 2 comes down, and the plus 1 comes down. So now, this was me foiling. Second thing I want to do is we are going to distribute our coefficient into those parentheses. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 8x, positive 16x. Negative 2 times positive 16, that's a negative 32. And then that plus 1 comes down. because it's not included in the parentheses, so we don't multiply it. Now, the last thing that we just got to do is just combine like terms. Here's the FOIL, and then combine like terms, in particular these guys, negative 32 plus 1, which just gives me my final problem, which is h of x is equal to negative 2x squared plus 16x minus 31. So for number 50 now. Same thing, convert. So what we're converting here is j of x is equal to x minus 1 squared plus 4. So like I said, first thing that we want to do is x minus 1 squared. So we're going to break that apart. We want to FOIL this. So x squared minus x plus 1. Simplifying that a little bit. Getting x squared minus 2x plus 1. And then bringing down this plus 4. But notice in this case, I don't have a coefficient up front, which is okay. It's really just one less thing to do. So I really don't need the parentheses, because we can see this as being an understood 1, and multiplying by 1 is not going to change anything. So really what I have here is x squared minus 2x plus 1 plus 4, combining my like terms. I get j of x is equal to x squared minus 2x plus 5. So for 51, 52, and 53, we're going to do the same thing every time. 51 just gives us a graph versus 52 and 53 give us points. So for 51, I'm just going to refer to the graph. I obviously don't have it here. Okay. And I'll quickly sketch the picture as best I can. So for 51, the graph they give us looks something like this. Just give me a quick second to get that doodled for you. Okay. So this is my x-axis. This is my y-axis. So I have a vertex at negative 2, 4, points at negative 3 and negative 1, 1. Let's see. Points at negative 4, negative 8. And 0, negative 8. So right there. Just can't see it. So this is what the graph that we have looks like. So they want us to write the equation. Keep in mind here, this guy's my vertex, which we said was negative 2, 4, which is going to be pretty important here. So to write the equation, what we need are two things. We need a vertex, which is going to represent hk, and we need any other point on graph. Which we'll say is going to be x comma y, just some random point on the line that is not already the vertex, because we already have the vertex. So what we're going to do here is, like we've been talking about today, to write a vertex form, because I have a graph, from a graph, the only equation we can really write from the graph is vertex form. So I've been writing vertex forms in blue all day. We'll follow suit. So for vertex form, y is a times x minus h squared plus k. This little guy tends to freeze at times. So think about it. What were the three variables that we've had to know to write the equation? I've solved for the same three variables every time. If you thought a, h, or k, you're on the right track. So the one thing I'm missing from all of this, notice, from these two sets of points, what's the only variable I don't have? I have an h accounted for, I have a k accounted for, an x and a y. Oh, I don't have a. So what we have to do is we need to actually find this a value first. From there, we'll have everything we need. Because like I've been doing, I need to know a, I need to know h, and I need to know k. From this problem, I have that covered already. In terms of the h and k, negative 2, 4. I know these, but I need to know that a. So how we're going to do that is we're going to substitute our vertex h and k into our formula. And then we're also going to substitute whatever point x and y into the formula as well. So in this case, my h and k, I'll erase this, we know is negative 2, 4. Where 2 is going to be h, 4 is k. So I'm going to pick any other point on the graph, and it does not matter which point you pick. So I'm just going to go ahead and pick this guy right here, negative 1, comma 1. So in looking at negative 1, comma 1, what that point is going to represent is my x and y value. So negative 1 is going to be x, 1 is y. I'm going to substitute these 4 points, or these 4 values, into my formula. So watch as I do that. So y equals, so my y value was negative 1. So I'm going to put this guy in first. So 1 equals a, I don't know that guy yet, times my x value, which is negative 1, minus our h value, which is negative 2, squared, plus our k value, which is 4. So obviously we can simplify these two negatives here. So really write this as 1 equals a times negative 1 plus 2 squared plus 4. So from here, once again, Pemdas. Pemdas always. So I have parentheses. I want to simplify this guy first. Negative 1 plus 2 is the same thing as 1. Keep in mind, this is multiplying by the a, adding by 4, and is equal to 1. Next thing is exponent. I have an exponent. 1 squared is 1. So a times 1 plus 4 equals 1. A times 1 is just a, plus 4 equals 1. Getting a by itself, subtracting 4 from both sides, I know a is negative 3. So now I know that missing value. So using these 3 values now, let's write the original vertex form equation. So my final equation here is y is equal to negative 3 times x plus 2 squared plus 4. vertex form. So the graph, you just have to pick out the vertex in any point, but noticing that the slight difference on 52 and 53, they're already giving us the vertex and they're giving us the point they want us to use, which makes the amount of thinking we have to do a little less. So 52. My vertex is negative 3, 2, and the point that they're giving me is 4, 7. So like I said, this is h, negative 3 is h, 2 is k, 4 is x, 7 is y. And these guys are getting substituted into the vertex form equation to find the a value. Working this, y is 7 is equal to a times x, which is 4, minus h, so minus negative 3 squared plus 2. Following Pemdas, I'll write that again. Simplifying the parentheses, that's 4 plus 3, which is 7, squared times a plus 2 equals 7. 7 squared is 49. 49 times a is just 49a plus 2 equals 7. Subtracting 2 from both sides, 5 equals 49a. Dividing both sides by 49. 49 does not go nicely into 5, so we're going to leave that as a fraction. It's okay if the fractions are gross, especially if we don't have to graph it. So I know everything that I need. I know the a, I know the h, and I know the k. We know what a is. We also know h is equal to negative 3. That's from our formula, or from what they gave us. We also know the k value, like I said, which is 2. So my final equation is y is equal to 5 over 49 times x plus 3 squared plus 2. $53. Gonna go a little faster here. So the vertex is 3, negative 1. The point is 0, negative 8. Plugging this in, I get negative 8 is equal to 8 times 0 minus 3 squared minus 1. That's 8 times negative 3 squared minus 1 equals negative 8. Negative 3 squared is 9 times a is 9a minus 1 equals negative 8. Adding 1 to both sides, negative 7 equals 9a. Dividing everything by 9, negative 7 over 9 is my a value. So I know my final equation is y is equal to negative 7 over 9 times x minus 3 squared minus 1, using the h and k values like we've been doing. $54. The only difference here because I'm graphing in this case, so we're going to still be doing the same things that we've been doing, is we have to deal with the inequalities. So for inequalities, two things you have to know is the line type and you need to know the shading side. The type of line that we draw is either a solid one or a dashed line. So solid is when my inequality is equal to. Doesn't matter if it's greater than or less than. It's going to be a dashed line if it's not equal to. So solid just meaning we're going to connect all of our points with a regular old line. Dash meaning we're going to actually draw little dashes. What that means is our solution for a solid line can be included in the shading area or on the line, and on the line. For dashed lines, the shaded section is the only section that represents our solutions. Now, to find where do I shade, because I'm going to shade above or below my graph, how we do that is if my inequality is less than or equal to, we're going to shade down or below the line. If it's greater than or greater than or equal to, we're going to shade up or above the line. Two big things you got to know there. You got to know this. So I'm going to be referring to this as I graph these lines. So for 54, I have y is less than 2 times x minus 1 squared minus 3. So we know how to graph from vertex form already. That's what we've talked about pretty in depth thus far. So the only thing that we got to focus on here is how is the inequality going to affect this graph? So we're going to look at this guy and write down the two things we know. So the first thing I know is that this is y is less than, not equal to. So what I know from this, since it's less than, I know this line is going to be dashed. And I know that we're going to shade below or down below the line. However you want to call it. That's what that inequality tells me. From the direction it's pointed and, got the highlighter, and from it being not equal to. The rest, we're just going to do as we know how. So, parent function table, xf of x. Negative 2 to 2. 41014. I'm changing the y values in this case by multiplying by 2 and subtracting 3 because they're outside the parentheses like we've talked about. Working those numbers out, what we have here is 5, negative 1, negative 3, and then the reflection of that, and 5. X values, x lies, keep that in mind. So we're going to actually do the opposite, so add, which is negative 1, 0, 1, 2, and 3. So these are my coordinates. So graphing this, I'm going to plot my points first. So -1, 5, 0, -1, 1, -3, and then my other ones. So we said that the line is going to be dashed. So doing the dashed line, so I'm going to do the dashed. So I'm just going to obviously just draw dashed lines through that guy. And we're shading down below the line. So what we mean by down and below, if you don't know how to find it, what I always tell my students is that if you put your pen or pencil on any point in particular, I'll say what if I'm putting my pen or pencil on the vertex, so right here. And if you go the direction the shading is in, so down, what side of the line are you on now? So we're on that. I'm obviously on, I'm going to get a highlighter. I'm on this side of this line, okay? Not on this side. So all of this is what we call the below or down part of the shaded section. So all of the shaded area, with the exception of my physical line, represent possible solutions to this inequality. And that's all we have to do here. So for the next bit, $55, almost at the end, I can feel it. So y is greater than or equal to 3x squared minus 12x plus 7. Obviously, we're in standard form, so we need to once again go from standard to vertex form. Keep in mind, my a value is not equal to 1. So what that's going to entail in this case is for me to do one of the two methods, okay? H is equal to negative b over 2a, or do I complete the square? When a is not equal to 1, we need to do h is equal to negative b over 2a. So what I would encourage you to do if you're looking at this problem is if you've practiced standard form up to this point in any past problem, I would pause here, try and work this out and get the vertex form, and then see when you press play again, the vertex form, check your vertex form with what I get, because I'm just going to write it out. I'm not going to work it. So the y and the inequality stay the same. The problem you should have gotten is 3 times x minus 2 squared minus 5. Working that table out real quick, I'm changing the x's and the y's, so I'm just going to preemptively make 4 columns. The y's we're changing by multiplying by 3 and subtracting by 5. So those values that I get, 4 times 3 is 12, minus 5 is 7, negative 2, negative 5, negative 2, and 7. X's we add 2, which is 0, 1, 2, 3, and 4. So these are my coordinates like we've been discussing. Graphing this now, what I know, once again, from the inequality is 2 things. This guy alone tells me that I have a solid line and I'm going to shade up or above the line. So it tells me two things there. So I'm going to apply those here. So 0, 7, 1, negative 2, 2, negative 5, and then plotting the rest of those. My line is solid, so just a regular old line. So above in this case, same thing. If I put my pencil on the vertex and go up, I'm now on this side of this line. So everything here is the up section, and it's solid, so my line, or the points on my line, also can represent solutions here. So that's my graph. So for 56 now. I have f of x is less than or equal to x plus 1 squared plus 3. Keep in mind, f of x is the same thing as y, so if you really need to write that out, you can go ahead and do so. Where's my work? Here we go. Lost it for a second. Same thing. So vertex form, which means I can graph it right out, draw that table. I notice that I'm changing the x's and the y's because I have numbers inside and outside of the parentheses. So writing these out, keep in mind, I don't have a coefficient here. So what I'm going to have to do is multiply, or not multiply, but I'm just going to be adding my y values in this problem. I have a little technical difficulty there. So in this case, I'm just taking the f of x values and adding 3, and the x values we're subtracting 1, x lies. So I get 7, 4, 3, 4, 7, and then negative 3, negative 2, negative 1, 0, 1. These are my coordinates. Graphing this real quick. Plotting my points. I'm just going to plot those in red so you can see them. Negative 3, 7. Negative 2, 4. Negative 1, 3. And then plotting the rest of those guys. This line is solid because it's an equal to. And the shading here is y is less than or equal to. So the shading is going to be down below the line. So in this case, all of this section. So everywhere there, including the line in this case, because it is solid. So the last one here, which looks a little wonky, but is actually really easy, is they give us y is greater than or equal to 4x squared. So people can sit there and go, oh, but is this vertex or standard form? Well, really, it's kind of both. So seeing it as vertex form, we don't have a number inside the parentheses, and I don't have a number added or subtracted at the end. So really my h and k value here equals 0, because really what I have is just an a. So if you want to see this problem, so you want to see this as 4 times x minus 0 squared plus 0. Hopefully you agree that that's the same problem. We don't write zeros when I'm adding and subtracting. It's kind of wasted space. So really, all I'm changing here are the y values by multiplying them by 4, because the 4 is outside of the parentheses. The x's are not changing, because looking at my original problem, there's nothing inside of my parentheses here. So my x's are going to stay the same in this problem when I'm extending my table. So the only thing that's changing are my y's, so I'm only going to add to the y column and say that we're going to multiply those y's by 4, which gives me 16, 4, 0, 4, 16. So my original x's and my new y's are my coordinates. So if the x's change and the y's change, then we use both of those new columns. If only one of the columns changes, we use the original column that didn't change, and then the new column that did change. So in this case, the x's did not change, so we're going to use those x's still, but now we're going to use a new set of y values because we changed them. So graphing this really quickly. So 16 we really can't graph. I mean, I'm not going to scale this guy up to 16. So if you want to kind of pretend 16 somewhere up high, you can. I'm not going to. So I know I have 0, 0. I've got negative 1, 4. I've got 1, 4. And I know 16 is somewhere, I mean, if we really wanted to extend my graph, I mean, we've come this far, right? 16 is 5, 10, 15, 16, all the way up there. You don't have to do this. I'm just doing it because my graph has actual squares on it for me to graph it. Now, shading though here, solid line, hence I drew a solid line, and its y is greater than, so my shading is up above the line. So everywhere in here and beyond. Okay, well guys, thank you so much for sitting in on this, or if you just kind of have been watching sparingly for particular problems, but I just want to say a big thank you for spending however long this video lasted, too long. Okay, thank you for sitting in on this. Okay, my name is Coach Fran. Should you ever need anything from me, and good night.